Okay, homework. Box and whisker plots. So, the question I asked you was to match those. Now, obviously, you can just go from the back of the book and find the answers. So, let's discuss why you think each one is what it is. Evening. So, don't blame someone else, it's being recorded. So, which one goes with which and why do you think?
C.
C.
And I.
C and I. What is your reasoning for it?
Because, well, on every diagram you can see that 0 to 1, it's absent. So all you can see.
Right, so there's one thing. The minimum for each one is 1.
And you can see it on every.
On all of them, so that's one thing. The maximum on them all is 10. Alright, so there's certain things to look at. That doesn't help you differentiate at all. So, yeah, go on.
But you can see that the interquartile range.
Yeah.
From third to the middle to the median. From the median. No, in C.
In C.
In C, okay.
And from the
here
median to A.
To here to here.
It's the interquartile third equal, you know.
Yeah.
And so that makes you think that the spread should be even.
So we've got, you notice how 25% of your data is between 1 and 3. 25% of your data is between 3 and 4. 25% of your data is between 5 and 7. And then the only one that's slightly different is 25% of your data is slightly more spread out than between 7 and 10. So we would be looking for data that is quite evenly spread there. Right? So, which one does it suggest if there's quite a nice even spread? I. So this would suggest, 1 to 2, 3 to 4, 5 to 6, 7 to 8, so on. It's all exactly the same. So that would suggest that I would go with C. Right? So, anyone have any disagreements, or do you think you're happy with that, or do you see why? Mm-hmm. Yeah. What about the other two then? What do we think?
B is 2.
B is 2. Why? That's what I want. I want whys, because trouble with homework set from questions in the book, the answers in the back of the book. So you can always tell me the right answer. I'm not saying you did. I'm saying I need a why. I need, especially in these cases, I need a why. Yeah. Nikki?
The median is slightly more to the right.
So the median is actually 6. Okay. Yeah.
And so it would suggest that the data is higher than that one.
So the median would suggest it slightly, but also this 25% and this 25%, there's a slight stretch for the 25% of people on the lower end. Okay, so that means that this bit should be more spread out between 3 and 5. Between 3 and 5 should be quite spread out. Does that agree with it? Because this one, look, the median is also 6. So you're saying that B goes with this one because the median is to the right hand side, but so is this one.
But that one, the values under there.
They're not what, though?
Well, because the two, like on B, it doesn't. The one
So the box doesn't stretch across the two. So what does that suggest?
That the median's in 6 a lot.
But median is the 6 here as well.
The data
That's why the
is-
line's there.
The data is less spread out from the quartile to the
So this one is less spread out in the box. So how many? Let's just go for one extra thing. I know you might say, "Oh, it's really easy," but obviously you're struggling to describe this. How many people are in graph I? 6 times 5. So we have 30 people. Okay. Is it the same here?
No, it should be
Might not be. It's obviously not people either. But
Wait,
I don't know. So we've got 4.5, 7, 8, 4.5, and 3.5. So what does that add up to? So 9, 17, 24, 27.5. And what about this one? So we've got 7.5, 2.5, 5.5, 3.5, 8. How much is it?
27.
This is 27. There's actually a different number of people in each. Obviously, that doesn't really matter. Let's decide how many people in a quarter. So, 30 people divided by 4 means what? Pardon? 7.5. I don't know why I'm saying people, by the way. So each quartile should have 7.5 in it. Alright? What's 27.5 divided by 4?
6.8.
6.8. What's 27 divided by 4?
6.8.
6.8 again. So we want to go for 6.9 here. Okay. So what that means is each quartile should represent the first however many. So for instance, this one, 6.8 people should all be within 1 and 2. So the first quartile must only be quite narrow. Does that make sense? And this one, the final 6.8 people are all in 9 to 10. So I've got 25% of my data both in the very extremes. So this one suggests that in the middle everything is spread out, but at the ends it's very close. Does that make sense to you? So this one really needs to be this one because of, remember that box, that little section there has to be a quarter of my data. So it makes sense that that would be, so 6.8 people fall just in that little box. Same at this end as well. 6.8 fall just in that little box. And then because of all this low frequency in the middle, everything in the middle must be quite spread out over several groups. Yeah. So 5.5, 3.5, 2.5, there's not enough to make a whole 6.8 in one block, so it gets spread out over a couple of blocks. Does that make sense? So this one, we've got 6.9. Now, the 1 and the 2, there isn't enough for the first 6.9, so this has to go sort of a bit into the next box to get the 6.9 that I need, yeah? Then, the rest of it will probably be in there quite easily. The next half quarter will be in this box, very close, yeah? And then we spread it out a little bit. So this one should have, the box should be smaller and the whiskers should be a bit wider. Does that make more sense to you? Okay. So that would suggest that 2 might be, so do we think B and think A? Because of that. Are we still happy that C is this one? Yeah? Yeah? You're still happy? Yeah? Okay. So we really have to think more about the distribution of the data. Is that what the answers in the back said? Are we right, C, B and A? Like that? Okay. Well, I hope you did sit and think it through. Because again, like I said, with your exploration, I'm going to just introduce you a couple of words here. Engagement and reflection. You don't need to write those down. You're going to have plenty of opportunity to write those down, believe me, and do it. What engagement and reflection? The thing that we're doing now is this, reflection. So with your exploration, the biggest thing that you're going to be asked to do is show you're interested, so that's your engagement. Show that you've got ideas that you want to explore, but the reflection comes from your discussion and what goes next. So what we're doing now, by really looking into the distribution of data, we're reflecting on the shape of the data and therefore, what does that mean? You understand by that? Okay? So you are reflecting. Now, if you don't work on your ability to reflect on the data that is put in front of you, or the data that you collect for yourself, you will do badly in your exploration. So this is the kind of thing we need to make sure that you fully understand.
But in the test, do I have to
Tests and explorations are two completely different things. A test question would be, what is the median? Draw a box and whisker plot. Finish the box and whisker plot. Okay? Tick the statement that best goes with that box and whisker plot. That would be a test question. An exploration is another way of you to show your knowledge and your ability to communicate your methods. So if you can't discuss one of these things, it's amazing how many people would write an exploration. It quite obviously shows that all my data is at one end or the other. And what does that mean? Is it obvious? What does that mean about the situation that we're talking about? What does that? If they collected data on boys and girls, what does that mean about boys and girls? So what? The data is at one end or the other. What does that suggest? Yeah. How does it show it? That kind of thing. You've got to be able to discuss that. The number of, even this year, the number of explorations that have come back looking like they've been written by year 7s in their first attempt at writing projects. It's because the thought left right to the last minute, and therefore the reflection is just not there. And out of 20 marks for your exploration, 6 are for the maths. So 14 marks is for everything other than maths. Right? You can get a 5 or a 6 on your project and have maths well below the level of the SL expectation, just because of the way you talk about it, the way you write it, the way you communicate. Okay, so it's quite important that we do this. Right, what we're going to go on to next. Any more questions on box and whisker diagrams, by the way? No? Okay, let's move on to the next thing, which is it's cumulative frequency. Come on, move. Right. So I want you to be able to draw and interpret, again, this word interpret, a cumulative frequency curve. Right. So I guess from IGCSE, you should be pretty okay with drawing them now, yeah? So it's the interpretation bit, we've just got to check that we know what we're doing. Right. So, what does a cumulative frequency curve look like, do you remember? Yeah, kind of, but there's a generally recognisable shape for cumulative frequency. Okay, we've got it. Kind of like this, isn't it? Yeah? And the y-axis is not a frequency now, it's a cumulative frequency axis. Okay? And the x-axis is whatever it's about. So, this point at the end of my curve should show me what? So, on the y-axis, yeah, this should show the maximum frequency, so the total amount should be that value. Okay? And what should it show me on the x-axis?
The highest value.
Yeah, so that should be the highest value that we've got in our table. Now, do you remember how to read certain things off your cumulative frequency?
Well, for the median and the quartiles, because take the max frequency and you find half of it.
Yeah, so if I know whatever my max frequency is, I go to halfway,
And you just read it on.
read across, and read down. And this value here would be the median. So this would be 50% of the frequency, so 50th percentile. What about my quartiles that we've looked at with box and whisker? Yeah. So if I go 75%, read across, read down, and the same with the lower quartile, 25%, down. So this value would be my lower quartile, this would be my upper quartile, so the distance in between would be the interquartile range. Okay. And this point here would give me my minimum value, and this one would be my maximum value. So, if I were to redraw my scale, right, so, can you see how I can go from a cumulative frequency curve to a box and whisker? Is that a yes to everyone?
Yes.
Yeah? How would you do it? Michelle, how would you do it? How would I go from my cumulative frequency curve to box and whisker?
You would take the interquartile range.
Yeah, so I've got this value, read down, I would put a little line, take my median, line, upper quartile, line, minimum value, line, maximum value, line.
And then everything that lies on the outside of the
Well, the thing is, there isn't anything outside of that, is there? No, that is all my data. What I've got to decide is whether anything within that data it becomes an outlier, so I'd have to do 1.5 times that. But just to highlight, this axis here is that axis there for my box and whisker bar. Okay?
So do I just copy out from the graph?
Yeah, so literally, you take the same scale and you read down. So that would be minimum, right? Your median, you just follow it down. Lower quartile, follow it down. And upper quartile, follow it down. And your maximum value should just read down. So that would be my box and whisker. Right? And I draw them. So that much better. Much. Right? Now, so hopefully you'll be able to see from my cumulative frequency curve, how does a cumulative frequency curve show the distribution? So I'm not going to say now, I want you to discuss it just 2 minutes. I want you to think of the different shapes of those box and whiskers. I want you to go along with these box and whiskers. I want you to try and sketch the cumulative frequency curve that would go with this box and whisker and tell me what effect the shape of the curve have. Do you understand what I mean?
Can you explain?
So for instance, take the box and whisker, sketch it to the side, and say, well, this box is a lot wider. What effect would that have on the cumulative frequency curve, for instance? How could I see from the curve that the box was going to be bigger or smaller, or, you know, do you understand? So I want to know kind of the effect of what would I see happen, change in the cumulative frequency curve that would lead to a change in the box and whisker. That's what I want you to discuss with me in a sec. Okay, so before you have a look at this, right, now what I'm saying is, if we want to change these lines here, the size of the box, we're going to keep minimum, maximum exactly where they are. So that point and that point can't change. What also can't change is the fact that that's 25%, that's 50%, that's 75%. They can't change either. So what does the line have to do to spread the box out? Well, if I want the box to, so if that's minimum, that's maximum. If I want the box to start here, for instance, what has to happen to the curve? So from this point, it has to reach this line quicker.
It has to be.
Has to do it by there. Yeah. So to make a section smaller, shorter in the box and whisker, the line has to get steeper. So if I want a short bit here too, this final bit has to be steeper. Okay. So it kind of has to do this down to that point there. Yeah. By making these two bits steeper, what happens to the box? And what happens in between?
It's going to be more horizontal.
So it's going to be like that, isn't it? So it's not as steep. Right? Now the reason is because the frequency doesn't go up as quickly, therefore the line will be less steep. Now in this case, the median would be exactly the same, yeah? How do I shift the median, so if I get rid of that line in the middle, how do I shift the median down the curve?
Make the box on the right side smaller than one on the left.
Okay, so what has to happen to the line? So it has to be,
Steeper in the place.
so yeah, so we have to have the first bit has to continue being steeper, and then the next bit needs to be, alright, less steep. So, what we can see from our cumulative frequency curve is that the steepness of the line will affect the shape of the box. Now what that means is you can look at cumulative frequency and discuss the distribution of the data and how it's spread out, again in terms of quartiles and things like that. Now again, this classic shape of cumulative frequency suggests what about the data?
Which one?
The first one, the nice S shape. What does it suggest about the data?
It's equal to square, no?
It's like
So it's just an okay now bell-shaped normal distribution. Just suggests a nice even thing. Okay. I'm going to ask you, please. You are going to sketch some things for me, right? I would like you to sketch 3 cumulative frequency curves for maths results. Okay, so you are going to sketch 3 cumulative frequency curves for the different situations. Okay, 1. So it's about a maths test. High achieving, low spread. Okay. So I want a curve that shows me high achieving, low spread. So high achieving would be good results. Low spread means not much spread of results. Okay. Second one, okay. You're going to show me an even spread of results, okay, but not that high achieving. Okay. Question 3, large range of results. Okay, large range of results from poor to high, with more good results than bad. So I would like you to think about what would the cumulative frequency curves look like for those 3 situations, and sketch those for me. Let's have a quick chat then, guys. So, first graph. So for me, let's assume that we've got 0 to 100% test results on both of them. So 0 to 100%, 0 to 100%. The actual frequency, so the cumulative frequency, I don't care, but let's assume that they're all the same. Alright? So I could just say that on all of them, my graph has to reach that level. So that's the max frequency for each school, whatever it is. We've talked exactly the same number of people. Okay with that? So my graph should start at 0, because that's like where it, so 0 on the frequency and go up to maximum frequency, because it always does that with cumulative frequency, from 0 up to the maximum frequency. Now the question is, what will the shape of the curve look like? So I've got high achievement but low spread of data. So that means that generally everyone in that school does very well. So where's the starting point? So let's talk about the minimum possible score. What effect does it have on the x-axis?
it wouldn't be at 0 on the x-axis because
Yeah. So let's say, what would you consider a high achieving school? Minimum score probably wouldn't be any less than 50. So my curve might start from that point there. So it might start around there. Come on. So it might start there. Therefore, it's got to get from there to the maximum quite quickly. Okay? So I reckon maximum now, if it's a high achieving school, there'll be a lot of people at that top end, yeah? So that means at the lower end there probably isn't that many people. So how do you show not many people at the on a cumulative frequency curve? No, opposite.
It's already
It'd be quite flat. So we would actually have a curve that starts relatively flat because there's not many people at that end. Then, once we get to a point, probably it goes up, alright? And it keeps going up and probably has a slight tail at the end. Alright? It might even just go straight there. You never know. So we've got quite a steep curve. Right? If I wanted to make it even better results, I'd have even more of a flat curve and just go straight up, like that. If I wanted to make it slightly worse, I'd have a curve that kind of could go up like this. Right? All of them would show high achievement, not much spread. Okay with that? So the next one then was even, what is it? What did I say?
Even spread, not that high achieving.
Even spread, not that high achieving. So, for instance, not that high achieving, the maximum mark is going to be slightly lower. So maybe I only go up to that point. So I only achieve maybe 70% or something. So it doesn't go all the way up. Even spread would suggest
It's kind of straight.
kind of straight. So there's always some tail at the beginning and end. How low shall I go?
0.
Potentially 0, maybe just slightly above. I'll be a little bit generous. So I might have a kind of something like that. Okay. But even spreads, there's not much tail at either end. Okay. And then finally was,
large range of results,
yeah.
and there was more good results than the last one.
Okay, so large range suggests that we're going to go from 0 all the way up to 100, maybe, or just under 100. Right, so we're going to use the whole graph rather than part of it. Right, and we want slightly better results than worse results. So how do we show that? Where? At the end. So the beginning needs to be
Quite flat.
a bit of a tail up, and then we go up. Okay. Okay, so we've got a large range of results, but so we can see from this, look, what effect it has on the median. So obviously the median line is going to be a line kind of through there. That's the median. But you can see for this one, for instance, let's take this middle one, the median is really quite high. The median here is lower, which is kind of what I suggested I wanted, slightly lower results. And this one, the median is a bit higher. Okay, so you can see how the distribution of the data affects where the median is going to be. Right, so that tail at the beginning and the end, right, does affect things. Make sense? Right. So we covered those things. Right. Are you all right? So the next thing we're going to look at, so this is your book. So let's have a look now at, are you all happy with drawing your cumulative frequency curve? Okay. So I'm going to ask you to do that question 2 for me. Right. So page 273, question 2. I've got some graph paper, so you can do it. So have a look at the example if you need, otherwise just go from that table and draw your graph. Okay, happy with that? Okay, good.